We're at Algebra 2. We're going to solve second-degree systems graphically in 10.6c. If you haven't seen the previous videos, we're up to 21 now. If you become lost or confused, you can just click on the description and watch the videos you missed. When we studied systems of linear equations in Chapter 4, that was videos 4.4a and 4.4b. There'll be a link to those too. We solved them both graphically and algebraically. Now we have systems in which one equation is of the first degree and one is of second degree. We use graphical then algebraic methods to solve these. Now remember that a solution is an ordered pair that satisfies all the equations in the system, all the equations that are involved. Solving a system graphically will not always give us exact solutions. So remember, if we see a little exponent of 2, that means we've got an equation in second degree. And if we don't see an exponent at all, it's an invisible 1 exponent, and that means it's an equation of first degree. Okay? For a system of equations, an equation of a circle and an equation of a line, we can think about the possible ways in which a circle and a line can intersect. So we've got these three choices here, and the first one has no point of intersection. The line doesn't touch the circle. So the system of equations has no real solutions. In this one, it's touching it at one point. It has one point of intersection, so it has one real solution. So guess what? This is touching it at 2 points. It has two real solutions. So we can solve this system graphically. We've got x squared plus y squared equals 25 for our circle. And we've got 3x minus 4y equals 0 for our line. Let me fix this. And this is our graph right here. We can see it's touching at 2 points. It's touching at 4 for x and 3 for y, and negative 4 for x and negative 3 for y. These are the points where it's touching the circle. And we graph the two equations using the same axis. And the first equation is of the graph of a circle, and the points of intersection have the coordinates that must satisfy both of these equations. So the solutions appear to be 4 and 3 and negative 4 and negative 3. And these values satisfy the equation, so we have our solutions. We can take these and plug them into the circle equation. We get 16 plus 9 equals 25. That's true. And if we do negative 4 and negative 3 and put them in, we still get 16 plus 9 equals 25. And that's true. And if we put these into the second one, the second equation for the line, it makes it true. So we have our solutions. Okay? Now take a look at this. We've got a circle and a hyperbola intersecting. And the intersecting points are real possible solutions. So here we've got the branches crossing through the circle. We've got 4 points of intersection. We've got 3 points of intersection. Now we've got 2 points of intersection. Here's another way that it can have 2 when this branch isn't even touching it. Now this one's not touching, this one is. We have 1 point, and here the branches aren't touching it at all. And that tells us how many possible solutions there are. So we can solve this system graphically if x squared plus y squared equals 25 would be our circle, and the quotient of x squared and 25 minus the quotient of y squared and 25 equals 1 for our hyperbola. We graph the two equations using the same axis, and the first equation is of a circle and the second a hyperbola, and the points of intersection have the coordinates that need to satisfy both of these equations. Our solutions appear to be x is 5, 0 is y, and x is negative 5 and 0 for y. We check it by plugging those values into either equation, and we get 5 squared equals 25 and negative 5 squared equals 25. See? So we could check it at the same time. It makes it equal 25 like it's supposed to. And for the hyperbola, we can see that it'll make it equal 1. Now our solutions make the equations true, so they're correct. See how I did that? All right? This isn't really that hard, okay? So our next video is 10.7a, and we're going to solve the systems with first and second degree equations algebraically. I'm going to add this to the Algebra 2 playlist, and there'll be a link to the previous 21 videos and those two for systems of linear equations that I talked about in the beginning of the video. All right? So I hope you're having a great day, and I hope this was helpful, and I'll see you next video. Okay? Bye.